Hello everyone, it's Problem Solving with Miss Jones, and today we are going to do a constant acceleration equation problem. My recommendation is always going to be to sketch out what's happening and write down what we know. So we have a car starting at rest, and it's going to travel a known distance, 200 meters, at which point the tire breaks and then travels another unknown distance till eventually it is at rest. So there's three main points here. We have the beginning, we'll call that A, the middle, I'm going to call that B, and we have the end, I'm going to call that C. So these problems are tricky because it's not just an initial and a final. We have an initial and a final, and then another initial and final. So I'm going to continue writing what we know. We know the acceleration here is 12 meters per second squared between A and B. Between B and C, we know that the time it takes is 60 seconds. And the final velocity is 0. And we're asked two things, the total time and the total distance. So we know the distance from A to B, we're going to need the distance from B to C. And we know the time from B to C, so we're going to need the time from A to B. Now there's a couple different ways to go about this. All are correct. I'm going to start with A to B. Because I know three things already about the travel between A and B. And I'm going to go ahead and write the constant acceleration equations here on the side. Velocity final equals velocity initial plus AT. Velocity final squared equals velocity initial squared plus 2AX or D, whichever you prefer. Then we have X equals velocity initial time plus 1/2 AT squared. You may have another one. I pretty much just use these three. Okay, so I'm going to go ahead and solve for t. I have velocity initial, acceleration, and distance. That's x. And I want time. So the way I pick this out is look for the thing that's missing. So velocity final is not on that list. So I'm going to pick the equation that does not have velocity final in it, and that is the third one. So I'm going to go ahead and substitute 200 equals 0 times t plus 1/2 times 12 t squared. That's a good thing that's 0, so we don't have to do a quadratic. Solve for t. I recommend you doing that yourself. I got 5.77 seconds. Okay, so that's the total time. If we add that to the 60, so the total time is 65.77 seconds. That's one of our answers. And now we need the distance. I need the distance from B to C so I can add it to the 200. So one thing I'm noticing is that I only have two things, and all of these equations I have acceleration in it. So I'm going to have to find the acceleration also between B and C. But I need another given. And here's the trick. So we know from A to B we have initial velocity, and then we're going to have a final velocity here. But that final velocity will then become the initial velocity. So the final from A to B becomes the initial from B to C. So we're going to do that. I'm going to solve for final velocity. And now that we have time, we can actually either choose to use the second one. Maybe you try to use the first one and make sure we get the same answer. Bf squared equals 0 squared plus 2 times 12 times 200. And when you do that, you get velocity final equals 69.3 meters per second. And that becomes our initial velocity from B to C. So now I'm going to find acceleration. Let's use the first equation. So 69.3 equals 0 plus a times 60. And we get acceleration. Whoops, I plugged in the wrong thing. Should be 0 equals 69.3. That way we get a negative 1.155. Negative because it's slowing down, so that makes sense. And then the last step is to find distance. You can use this equation or this equation at this point. I'm going to use the second one. 0 squared equals 69.3 squared plus 2 times negative 1.155 times x. Okay, when you solve for x there, I got 2,079 meters. So the total distance is 2,079 plus 200. So 2,279. And there you have it. Thanks for watching.